Hello, good afternoon. My name's Adam Gravely. I'm Head of Technical and Innovation for the Future Homes Hub. Welcome to this webinar. I can see we've got many more people still arriving, so we'll just wait for a minute and let them arrive before we kick off. Okay, as you can see, we've got some good numbers in the room. There's over 100 people have joined so far, so we'll begin. Welcome to this webinar, the Future Homes Standard Consultation, what we've learned so far. We're joined this afternoon by a panel of experts in the room in order to give you a perspective and some insight in some of the conversations that have been happening in and around the hub over the last month or two, and also to answer your questions directly from the Q&A. So firstly, if I introduce your speakers. Joined from AES consultants, we've got Jon Ponting, a senior sustainability consultant. Jon's a senior, is tasked with unpacking and understanding the home energy model to help better build responses for the consultation. He's had experience with SAP and SBEM, and also now is making this his fourth approved document L consultation. Paul Hutchens, founder and CEO of Eco2 Solar. They're a leading provider of solar PV and associated technologies for new homes. They operate across all of mainland Europe, with many of the UK's largest and medium-sized housing developers. So Paul's also a director of Solar Energy UK and chaired its new build working group for nearly a decade. We have Chris Knights, Business Manager Compliance from BSRIA. He's worked for them for over 25 years and is currently focused on as-built performance. He's a particular interest in providing practical solutions that drive quality for both fabric and services. And more recently, his focus has been on ventilation and how we turn designs into something that provides effective indoor environment quality. And finally, we have from the hub, David Adams, our strategic advisor. David's been over the years a house builder, developer, manufacturer, and also with the Zero Carbon Hub, he has been heavily involved in advising on building performance. So welcome all of our panel today, and thank you for joining. I'd just like to, before we kick off, to invite you, if you have questions, you can drop them in throughout the presentations that will follow. We'll have brief presentations from each of the panelists, and then we'll launch into a Q&A for the second half of that. So at any time you can start to drop your questions into the Q&A. There's a chat button and a Q&A button, so please use the Q&A button to add your questions. And just to hit the first one that we always get, yes, this webinar will be recorded and shared on the Future Homes Hub website soon after this recording. So let's get started. I'd like to hand over to David Adams, who's going to give us an overview of the standard and build on the webinar that we had in December.
Adam, thank you very much. Good to be back here. Looks like we've got, oh my goodness, nearly 200 people on the webinar. So keen interest, as I guess we would expect. for the Future Homes Standard consultation and HEM. What I'm going to do is I'm going to give you a little bit of a quick whip through, a bit of an overview, but missing out certain key elements that people are going to be speaking on directly. And this is kind of scene setting. What we'd like to do is respond to your questions. So please drop those into the Q&A. And what we'll then do is talk around the areas that are directly of interest for yourself. But in terms of a bit of scene setting, the government at the beginning of the consultation set what they're seeking to achieve. And hey, look, this is exciting stuff. This helps the house builder industry to be on the right path for 2050. It's non-fossil fuel. As the grid decarbonizes, we get to that net zero. But also it's about other stuff, improving the quality of the homes, reducing running costs, keeping those bills down, and ensuring that homes are warm and comfortable to live in. There's also recognition, though, that yes, there is an increase in build cost inevitably from this, but it points to the wider benefits and the benefits for householders too. In terms of the performance requirements, many of you will have been involved with the Ready for Zero report that we undertook at the beginning of last year to help inform the consultation. The government are proposing option 1 and 2. And for those that have read the Ready for Zero report, that's both are very similar to contender specs. How shall I put it? Contender specs 2 and 1. The numbers are the other way around, so just be a little bit careful. But basically, the fabric being fairly similar to the 2021 fabric, with option 1, there is a replacement of the gas boiler with a heat pump, and with otherwise broadly the same, with some benefits and costs associated. Option 2 is again replacing the boiler with a heat pump, but not having the PV on the roof nor the wastewater heat recovery, and that has quite a significant impact on the running costs. Obviously, it also reduces the capital costs. So John's going to be talking about HEM. So I'm not going to speak about the notional and how the specification the government has come forward actually meet with these, line up with these. John will pick that up in a little while. In terms of metrics, basically the metrics are the same as the ones that we have today. There was a little bit of a surprise that there wasn't one about load shifting in there, certainly from a Future Homes Hub perspective. But they are, you know, as we've used previously, maybe later on down the road, in another version of the regs, in whenever year that might be, those metrics change. Certainly the HEM model would allow it. One you may have picked up on is the regional weather. Again, I'm going to leave that probably to John because he can pick up on it. They are giving a heads up on the real world performance of homes. And what I mean by that is they've asked a few consultation questions. So this is very much scene setting, but to look out for, where they're anticipating consulting on more detailed proposals for 2024, in 2024 for implementation in 2026, and encouraging the voluntary testing of homes. And there's a link proposed between that and the Future Home Standard, sorry, a potential Future Home Standard brand. That's being discussed at the moment by the Consumer Implementation Group. That is one of the 9 implementation groups that we have now running. And interesting, the bit of reaction from the implementation group, consumer group, was let's wait until we see what they've actually decided for the Future Home Standard before we get too excited about developing a brand. But you'll have your own views for the for the consultation. So HEM's being picked up. Building services is also being picked up by others. But worth having a look at some of the minimum standards. There are quite a few of these, and they are on, for instance, the insulation on the cylinders has been raising quite a few concerns from house builders. Physically, the cylinders would have to, subject to the proposal, get a lot larger. So one to look at there. And again, the other elements of those minimum standards we will get picked up. So I'll jump over them. Heat networks. Heat networks are being encouraged. I've not had a lot of feedback on heat networks. Let's see whether we get much feedback in the Q&A. But certainly I'm picking up from house builders that the proposals are generally welcomed. What do you think? This one's interesting, accounting for exceptional circumstances. So local authorities can't relax the rules on energy efficiency in regs, but they can on some of the others. So it's asking whether that should be allowed. It'll be interesting again for some thoughts from the floor. And material change of use. I hadn't appreciated, and maybe it's just me, that 28,000 homes, new homes in a year were built as material change of use. Really significant. And they are the worst performing homes. So they are ramping up the standards for material change of use and requiring it to be modelled. So again, it'll be interesting to see if we have any questions, comments about that. But one to be aware of if you haven't picked it up. And my final slide is about timing. So this is the backbone of the implementation board and implementation group process. We need to understand what does this timescale look like? Are the actions necessary to achieve a really good deployment of the Future Home Standard? Are they being undertaken? Where are we headed? And then what we've shown here is, in terms of the percentage build outs, these are the government's numbers. They're in the, I think, impact assessment, showing half of homes built in 2027 and close to 100% from 2028. And that we are working on assumption of the Part L, the AD, HEM, etc., being published at the end of 2024. I've shown the 12-month lead-in. There's a consultation about it being 6 months. Certainly, the house builders that have been feeding back to us are very much in the camp of a 12-month lead-in period, and then the 12-month transition period. So that's kind of what it looks like. And we are now refining these in particular to give what is the heat pump demand, for instance, likely to be, because obviously we need to look at different stages of the build. The build might take 6-month period. You don't need heat pumps on day one. So feeding that into understanding what the deployment looks like. So part of this is feedback to consultation. Part of it is to help us understand and what to plan for. So that's a quick overview. I'm going to now pass across to Jon to talk about the home energy model.
Cool. Thank you there, David, and good afternoon to everybody. As mentioned in the introductions, for those who aren't familiar with myself, I'm Jon. I work with AES, and I come from a background of SAP assessing, been SAP assessing for a good 15 years plus. And really since New Year, with these consultation papers that came out, I've now just turned my focus to the home energy model. In particular, just trying to interpret, appreciate these are still very early phases of going through consultation, but trying to interpret what this means in the real world, because developers are quite understandably wanting to know what this means for their sites, which they are already planning and budgeting for. So if we go on to the next slide there, David. Perfect, thank you. So I'm going to keep this quite bullet point and just at the top headlines. If anyone knows me will know full well that I can just talk about home energy model and SAP for absolute hours, and I've only been given 5 to 10 minutes for today's discussion, so I'm going to keep it very, very high end. If anyone wants to send technical stuff to me later on, feel free to. But yeah, the first question, what is the home energy model? Because it gets talked about, and we hear about it's been this brand new thing which we're going to use moving forward. So what exactly is it? It is that, well, the proposal is that it will replace SAP, and it was initially called SAP 11. Which I think has kind of given people this false idea that it's just another SAP rewrite. It is most definitely not another SAP rewrite. It is a blank piece of paper starting again, which does sound quite daunting considering they want to implement all this, but for 2025 regulations. There are a lot of similarities within the home energy model compared to SAP. So we are still modeling a dwelling and we're still looking at the energy losses. So we still have to put in things like dimensions, things like U values, things we're very familiar with, building services like heating, hot water, ventilation, that kind of thing. But there are quite a few differences in this proposal as well. David's already mentioned there about the figures looking at regional weather data instead of national. Now that shouldn't disadvantage certain regions over others, because both the actual and the targets will be using the same weather data. So really it should be comparing apples with apples. But it's just one of those changes which has been brought in really to make the home energy model more accurate, to give it a bit more of a real life feeling with the figures. Quite a lot of the arguments about SAP at the moment is that SAP is, well, it's a simplified tool, and it is simple. It is quite basic, and it makes a lot of assumptions. One of the ideas of this home energy model is it will make fewer assumptions. Another one of the differences is just the level of detail it goes into. So one of the key differences, I think, is this idea of it becoming more of a dynamic tool. So when you look at a SAP worksheet, it splits the calculation 12 times. It runs it for once every month of the year, whereas the home energy model is doing it from every half hour of a year, which is just over 17,500 calculations it's running every time you run the model. So it's a really far more in-depth look at the energy performance of a house. And as I say, by doing that, it's hoped that the results that are being generated will be more true life than what SAP is currently delivering for us. We move on to the next one. Thank you. So as part of this consultation tool, there is this home energy model beta tool that's available online. If anybody is familiar with previous Part L consultations, it uses the ISAP user interface. So it's an online portal, and it's been set up by the BSRIA, and you can feed data in and get the results out based on the consultation and what the current proposed targets are. It is still a work in progress, and it does have missing parts. And this is one of the issues that I've been having over these last few weeks when developers are coming to me saying, well, can you tell me how this heat pump compares to this other one? No, I can't. Can you tell me how infrared heating compares? No, I can't, because although this tool has been released, it's been released with a very limited amount of options available. I've got another couple of examples in there. There's no option to change the efficiency of any of the heat pumps or wastewater. So I can put in a wastewater, but it's just an on or off. I can put in a heat pump, and there are a few different sizes of heat pumps in there, but I can't override efficiency. So in terms of building services, it is quite limited. The fabric part of the home energy model to work out the fabric energy efficiency, that's pretty much there, I think. But in terms of what building services we can add, we are quite limited. It is slightly annoying because that is one of the critical areas which you can use to build the result. But hey, we are where we are. In terms of the additional information, now I put a list in here which, if you just read it out of context, could seem quite worrying, because the home energy model is asking for some really quite different information compared to SAP. As I mentioned, it still asks for things like U values and measuring of dimensions and stuff like that. But going into this level of detail, it does want to know a lot more stuff, particularly around M&E details. Now, what I would personally expect, because this is the consultation, by the time it goes through all the various loops and gets the feedback and ends up with building regulations, some of this will be scaled back. Some of this may well be dropped out entirely. May even be new things pop up before 25, who knows? But these are just some examples. So currently, if you were to model a home energy model in the consultation tool, you need to enter individual wall orientations for north, east, south, west, whereas in SAP, obviously, you just put in the one wall per type. It also asks for things like the color of the external surface, with the idea that a darker surface will retain more heat. At the moment, it's asking for U values for internal and party elements. We don't believe that's to measure actual heat loss, but it's to do with calculating the thermal mass and how quickly or slowly the internal construction retains heat and stores heat. At the moment, it's asking for a 2-zone modeling system. So anyone who's familiar with SBEM, where you have to enter each room in zone by zone, home energy model is kind of doing that. The living room is a completely different zone to the rest of the building. So at the moment, everything we put in is based on a 2-zone system. It's also asking for some heating details, such as radiator sizes and lengths of pipework. All this gets fed into the heating pages where it works out things like the thermal mass of the heating system. And I'm not an M&E, don't come from an M&E background, so some of this stuff is a bit lost on me. Yeah, these are some of the questions that I've had to learn very quickly to understand that I'm putting the right numbers in the right boxes. It lets you also change things like heat pump compensation curves. And I doubt whether that will come through to the final draft. If it does, there will be defaults or drop downs, because otherwise that is a very high level of detail for a typical assessor to be expected to know. And the final one I put on there is we need to record into the model the height and distance to nearby obstacles. If anyone's familiar with the old Code for Sustainable Homes, when you were looking at the possibility of overheating, you had to look at the surrounding buildings of the dwelling you're modeling. And that kind of, I had flashbacks when I realized that I had to do that. But again, this all feeds into this idea of making the model more accurate. We are aware that there are 2 options available, or in the consultation, they're talking about having these 2 proposals. Option 1, what does option 1 look like? Well, from the modelling that we've done so far, in nearly all cases, PV and heat pump is non-negotiable. We know that the idea of the 2025 regs is to come away from fossil fuel heating, so you'd expect heat pumps to be there in the most part anyway. There are concerns that the amount of PV that's required could push on what is practical on real life sites. Now, just the word practical, that is quite a subjective phrase to use. And I'm sure when Paul comes on to do his discussion from the solar side, his definition of what is practical would be different to maybe a developer's. But either way, wherever you stand on that scale, it could impact the planning layouts. It could impact the design of roofs, so that roof designs become simpler in some cases. And in the case of large sites, you could then have the issue of excessive generation, which then leads to the debate of having battery storage and going down that route. In terms of option 2, now option 2 is the I don't want to use the word relaxed, but it's the not quite as bad as option 1 route in terms of what the targets are going to be. Heat pumps would still be necessary, but we can see that PV wouldn't be necessary in a lot of the cases. In terms of the fabric performance, I've said it's minimal fabric improvement over the current standards. That's probably being quite generous. With option 2, it's pretty much the same as what we're currently building to 2021 regs, which does lead us to this potential issue of higher running costs, because if we're not improving building fabric over 2021 regs and we're changing from a gas boiler to a heat pump, just based on the running cost of electricity, and we know this does come up for debate time and time again, and we could be seeing that if we did go with option 2, yes, we'd be meeting this higher standard in terms of emissions, but we do need to be mindful that electricity is at quite a high rate at the moment. Now, I have put a chart in here to show options. I really need to heavily caveat this because this is not showing you that this is going to comply with 2025 regulations. This is showing you that last week in the home energy model, I put in this specification and it worked. Actually, I say last week, it was yesterday, because I did this last week and now the home energy model has been updated and things have changed. So this is even now during the consultation, this is still a moving target for us to try and pinpoint. But it gives you, if nothing else, it gives you kind of a ballpark. It gives you an idea of where we are heading. So just to run down option 1, I haven't followed the notional specification completely on this. And I didn't put the notional in here just so I didn't want to confuse matters. But I've got a wall U value in there based on 125 mil cavity. I think if you look at the U values, I think you'll think they're quite standard to what we're building today. I've got double glazing in there. Decent psi values. So I've gone with a bespoke psi value method with a heat pump, with wastewater heat recovery, And in this particular house, I've got 2.5 kilowatt peak of PV. This isn't a massive house, as I've put on there. It's 63 square meters semi-detached. As the home energy model gets more advanced, as we can actually put in specific manufacturers, as we can add in different technologies, I would expect that PV amount to go down. But as I said, when I ran this a couple of weeks ago, the PV was at 3.9 or something like that. So it is, as the home energy model is developed, it is getting a little bit smarter in that we can reduce the amount of PV. On the option 2 there, I've relaxed some of the fabric. I brought the wall down to 100 mil. Well, you can get 100 mil with 2.2, but maybe to 125 mils more cost effective. I've gone with system 1 ventilation in there. And I've removed the wastewater heat recovery and removed the PV, and that was getting me compliance to option 2. So I think this is my final slide now, just to say that I pulled out some advantages and disadvantages, pros and cons. The advantage of HEM, and I can see the advantages to HEM, even though I've been using SAP for 16 years. I can see that SAP is becoming a bit of a dinosaur when you consider other forecasting modeling tools that are available now. So the home energy model can be easily updated for new technologies. That's what we're being promised. Whereas if you try and enter a new technology into SAP, it can take a while to get it approved, and then even then it can be a very difficult process in SAP. The dynamic analysis gives greater confidence in accuracy, which is one of the, as I mentioned, it's one of the issues that we hear with SAP just not giving us accurate enough data. So the home energy model should go quite a long way to resolving that. And also the home energy model, the actual methodology and the calculation, it will be open to all. Anyone can see what the methodology is doing, and it will also be a multi-purpose tool. And by that, I mean SAP is just used for 2 things, to check Part L and to generate EPCs. The idea of having this home energy model is that we'll be able to use it for any kind of calculation method that we want. Anything that looks at the energy performance of a building, the home energy model can be used to feed into that in the future, one step at a time. In terms of disadvantages, the time it takes to create assessments and to run results, at the moment, it's a very laborious task. It's very time consuming. Again, that will improve as the home energy model is developed, as it becomes a bit smarter. But at the moment, it takes a long time to input the data, and it's not an instant result either. It can take several minutes to get a result out of it. As I mentioned previously, the consultation responses are going to be based on an incomplete tool, because the home energy model it's like having a jigsaw puzzle with a couple of 100 pieces missing. You can build it, you can see what the picture is, but you're still filling quite a bit of it in with biro. But it is being developed, and it will. We are being told that the home energy model will be there in plenty of time for the 2025 rollouts. And if left in its current form, SAP assessors will need particularly more M&E knowledge, but certainly there will be some upskilling to be considered to be confident that we're modelling accurately. So there are pros and cons to the home energy model. Okay, I believe that was it from myself. So I'll hand back over.
Thank you, Jon,
Yeah.
and good afternoon, everybody. My name is Paul Hutchens from EcoT Solar. We had an introduction at the beginning, so I'm sure some of you know me. Those who don't know that I run will need to know that I run a nationwide solar company, and we install PV pretty much all onto new build homes. Next slide, please, David. So just a bit of background on solar PV. Recent YouGov poll showed that 79% of MPs support solar on new build homes, as in mandatory on new build homes. And also, generally speaking, roughly 80% also, as it happens, of the public support solar. It's a very popular technology. There's been increased efficiency over the last number of years. So the panel average now is about 400 watts. And that's the kind of an average, a sort of sweet spot, really. There's generally based on economy of scale, there's a panel sizing that works most cost effectively, and currently that's around 400 to 410 watt peak. Although there are panels available and coming down the line of up to sort of 600 watt peak as well. Solar PV is very much become the mainstay of Part L. It's used in Scotland as well, and therefore it's a proven reliable technology that's proved popular with homeowners and also with builders as well. And it's a very reliable technology. It's pretty low maintenance. And interesting, this was mentioned by David in terms of the Future Home Hub contender specifications. Last year, I was involved in the pre-consultation, and there were 5 specifications. Number 1 didn't include solar at all, and number 5, the outlier at the other end, if you like, was beyond passive house, was an energy neutral house. And we kind of expected that, you know, this would kind of fall in the middle. So it was a little bit surprising to find out one of them was actually contender spec one, which was no solar at all. I just put in things in a little bit of context. The Part L consultation that came out several years ago now estimated that probably around about 2.5 kilowatt peak would be required to meet the standard on an average sized home. And actually what we're seeing being deployed in practice is more like 1.5 to 1.7 kilowatt peak by the time the energy consultants have got their hands on it and worked their magic. So actually, you know, generally speaking, these things tend to become less than is anticipated in the first instance in our experience so far. And as far as the FHS consultation is concerned, the estimate is around about 3.6 kilowatt peak. But interestingly, when Jon presented his slide yesterday, when we did a bit of a run through on this, a house he was looking at was coming in at 3.9 kilowatt peak. Now they've done an update overnight and it's coming in at 2.5. So that is obviously a dynamic thing. And I think also, but please bear in mind, this is a consultation. So, you know, if the answer is we want PV, but we can't fit this amount of it on, then maybe that's a response that needs to be put forward to government, and hopefully they will listen and understand this needs to be practical as well as a way of meeting net zero. And next slide, please. So 2 key options we talked about before, both got air source heat pumps. One's got PV, wastewater heat recovery, ventilation, and a higher level of air tightness compared to option 2. And the actual wording is that for PV is that high efficiency solar panels covering the equivalent of 40% of the ground floor area is what's required. That's the same as was the case for Part L. However, the conversion factor has been reduced, area to power reduced from 6.5 to 4.5, which we believe is due to the increased efficiency of the solar panels. Obviously, again, that's part of this consultation, so that may change when it comes out in its final form. Now, we think that this kind of focus on electrification and the changing carbon factor, therefore, and the whole philosophy of government seems to be if we can electrify everything and then we can decarbonize the grid, it's kind of job done. So in a sense, things like PV panels, for example, or let's face it, even windows are not necessary from a carbon perspective if you know, if carbon is if electricity is carbon free. So I think this changes the focus a little bit to, you know, impact on the grid. So, you know, if we're putting air source heat pumps in every home and maybe a couple of EVs outside instead of, you know, some petrol cars and a gas boiler, that could increase the home's use of electricity energy by, you know, roughly about 3 times. And obviously that's got to come from somewhere. It's got to get through, you know, UK Energy PLC, and that involves potentially a lot of upgrades to the grid, which could be offset by microgeneration. Secondly, decentralized power and the home of the future with microgrids and virtual power plants and energy management systems, being able to do peer-to-peer and arbitrage and those kind of energy models that a lot of companies are working on, does require a generation engine, which will be locally solar in most cases. And lastly, the impact on consumer bills can't be underestimated. Next slide, please, David. So this is from the consultation, and this is showing you what the impact is on energy bills of the new standard. And rather disingenuously, they've included the typical existing home and made that comparison. But actually, I think the realistic comparison is the baseline is the current standard that's in force now, where the expectation is an average of a £640 a year energy bill for a house. Under Future Home Standard Option 1, that drops to £520. But under Future Home Standard Option 2, it increases to £1,220. So it nearly doubles compared to the current standard. Now, of course, they're comparing it to previous homes, which of course could have been built any time. Which, in my view, is like saying we're meeting the minimum wage from 1983 or something. It's kind of irrelevant what we've done before. You've got to meet the current or the previous standard. That's what your comparison is. And obviously, the offset of that is the fact that the cost of Future Home Standard Option 1 is going to be more expensive than Option 2. But that's the trade-off, I guess, isn't it, that we need to consider in the consultation. Next slide, please. Interestingly, again, when you look at non-domestic buildings or material change of use from commercial to domestic, there is no kind of exemption or any option not to have solar. So the consultation for non-domestic buildings offers a preferred option with quite a lot of PV, and a second non-preferred option that uses those words with a bit less, but still quite a bit of PV. For a material change of use, which they're looking to do on a whole building approach now, really, as opposed to the basis of they have at the moment, which splits it into various sections, is that it will have high efficiency panels covering 40% of the ground floor area with with another option. There's no option 1 and no option 2. So I think that in conclusion, this is a consultation. The view of our view, which is my company and the solar industry view, really is we want solar on new homes, but we don't want it to be impractical or to be at a level that most house types or many house types can't meet. So I think the consultation needs to reflect that, really, that we want PV, but we don't want it at a level that's not going to be workable. Thank you. Oh, sorry, I'll hand over to Chris. Sorry, I've not done an introduction there. Sorry, Chris.
That's fine. There's no problem. Good afternoon, everybody. So we're going to have a look at Part F and the implications for the proposals in there. But what I thought it would be first be useful to look at is currently where we are. So if we can pull up the first slide and click again, we'll get both graphs up. Perfect. Oh, it's gone. So what that was going to show you is that currently we have a bit of a problem. So 40% of everything that BSRIA tests isn't compliant with the flow rates, airflow rule requirements for Part F. And if we look at clients where we work for them the first time, that number goes up to around 80%. And there are various other studies as well that show similar type things. So we're not achieving what we've intended to set out to achieve. And it's quite clear looking at Part F where they're concentrating on that. So if we could go to the next one. So there's 3 sort of key areas really. Competence, so who's doing what and how they're doing it, the products that we're putting in, and how we're checking that actually works. So if we deal with competence first, there are this is something that's new. So historically, there hasn't been a requirement to be a member of a competent person scheme, for instance. Pretty much anyone could do what they wanted to. So now we have self-certification by a registered competent person scheme. The alternative option to that is to provide notice to the building control body that the person who's doing the installation isn't registered with a competent person scheme, and then they will determine a series of inspections and the measurements that are required to be done. So we have training at the moment, and we do have competent person scheme, but we've still got that problem there. So what's going to change? Well, I think one of the important developments is there are going to be new national occupational standards and minimum technical competencies, and these are things that drive the training requirements and ensure that there's ongoing competency for those installers and testers. So that's a move in the right direction. If we have a look at product, so the next thing to look at here, and I suppose the most impactful change is around ducting. So we're basically seeing the end of flexible ducting for decentralized systems, so intermittent extracts and decentralized MEV. So there is no flexible ducting allowed at all, and that includes not even from the duct into the spigot of the fan. The other consideration is that where you're using rigid ducting in those 2 scenarios, the maximum length that can be is 2 meters. So basically, if you've got a wet room where that room is in the middle of a property, i.e. not on an external wall, you're being driven towards potentially a centralized system. In the case of a centralized system, again, you can use rigid ducting or semi-rigid smooth ducting, are 2 viable options there. Okay, so that's where we're looking to go. In terms of measurements, there are some new additions. So it's a requirement now to measure the static pressure in the ducts. And why has that been brought in? Well, if you've got a high static pressure, that brings with it another series of issues such as noise, etc., overloading on the fan systems, which is going to decrease their life. There's also a requirement to measure the power. So you may recall, if you like this type of thing, that back in 2010 there was a requirement also to measure power. I don't think it ever got done, but that was with a view to working out the specific fan power. And that's come back again. What's interesting though is nothing's done with that data. So it's recorded, but there isn't any compliance checks on it, unlike the static pressure in ducts where there's limit values that must be met. But with power, it's just been collected at this point in time. So that's probably a heads up to where it's going to in further editions of regulations. We move on. Now, this is potentially one of the big changes, is the way in which we measure ventilation performance. So most people are probably familiar with a piece of equipment that you can see on the right there, which is a vane anemometer and a hood assembly. You are probably unlikely to have seen a power flow hood, which is the device on the left. Now, what the consultation says is that you can only use vane anemometers on system 1, so intermittent extract installations. You must use a powered flow hood, and it's probably useful to understand what the difference between the two is. So the vane anemometer is like a windmill, and it requires energy to turn that, and that affects the fan performance. So if you were to think of it as a Ferrari, your fan being a Ferrari, it's got a top speed of 200 miles an hour. If you put a caravan on the back of that and look at the speedo, you're probably only doing 150. So it's not fair to say that the maximum speed of that Ferrari is 150, and that's the impact of the measurement equipment on the fan that you're measuring. So with a power flow hood, it applies no resistance to the measurement. So what you see is what you get, and it's an accurate measurement. So in previous editions of, well, not actually in Part itself, but in associated documentation, there's been something called the minimum benchmark method, which has meant that you could use a vane anemometer, and there was a correction applied. So for instance, for a 15 litre a second fan, if you observe 12 litres a second, that would be accepted as a pass. There's no mention of that, and it's my understanding there'll actually be a mention in there that it's not to be used. So in real terms, if you're using intermittent extracts, you would have to, and you're measuring them with a vane anemometer, you'd have to oversize those to get the flow rates that are required. Okay. There's been a lot of tightening up on the requirements for this equipment as well in terms of calibration. So these things haven't been calibrated as systems, although it's been a requirement. So that's further reinforced in these regulations as well. And that's a whistle-stop tour of the key factors for you. Thank you.
Well, thank you, Chris, and thank you to all the panel for those presentations. Really good to get that insight. We have around, let's see, around 20 minutes left just to look at some questions from the floor, and we've had many questions. I want to try and group it in themes if I can, so to ask several questions at once. There's certainly some questions, John. If I come to you first around HEM and around different types of heating system and potentially where these could go. So some questions around modulating heat pumps and infrared performance. So it's HEM's only just been updated, but does the introduction of modulating heat pumps make a significant difference to primary energy and the PV requirement, do you think?
Well, we've certainly seen an improvement, yes. So last week we had two heat pumps to choose from on the drop-down list, and now there's about 6 or 7, and these ones now modulate as well. So rather than just being all or nothing, so that has made a difference. And that example I said about dropping the PV from 3.9 down to 2.5, that's because we we were able to change to these new heat pumps that have just been added. So yeah, that's a really good example that the home energy model is still being worked on, and as more information gets fed into it, the more accurate it becomes, and therefore hopefully the more PV or the less PV we will need to put onto these designs.
And I know that the modulating control is this is basically drawn from a question on the previous webinar in December, actually, where they asked about modulating control, made the point that you know, air to water heat pumps are most efficient when operating continuously, but is having that control, is it well represented in HEM, do you think, compared with SAP? From what you've seen so far in the modelling, does the controls factor make a big or a good difference?
I think certainly this half-hourly changeover does make a difference, because in SAP you have one box where you put in the COP efficiency for a heat pump, whereas in the home energy model it's got something like 6 or 10 different COPs depending on what the external temperature is, what the load on the heat pump is, and it can pick and change its COP. So in terms of that, I'm assuming the controls that you put into that will control the COP and the whole efficiency of the system as well. And because that's being measured every half hour, that's giving us that much greater level of detail, which should be making the use of heat pumps far more accurate.
Thanks. So the modelling, the theoretical modelling, then should be much closer to the fact, and and that is, I think, probably a big step forward with HEM. The ambition that we see there from the government is fantastic. Perhaps I want to come to you, David, and just ask about as-built performance. There are a few questions in the chat around whether actual performance data can be entered and where Part L photos will be used. And do you and this does cross over with HEM, Jon, so also feel free to chip in. But what's the current proposal on how the as-built performance could be measured? Is there anything in the consultation which deals specifically with that?
So the consultation it's very high level at this stage, Adam. They're just some early appetite testing questions, I would describe them as. They're highlighting that a much more detailed consultation will occur during 2024 with a view to implementation in 2026. So it's a bit of a heads up, really. From a HEM perspective, it is really interesting, these wrappers that you can put around the sort of the building physics model of the house, yeah? Because as you and I know, if we were to live in the notional house, the weather isn't notional weather, and the internal temperatures aren't likely to be the notional temperatures. They'd be the temperatures you or I heat it to, yeah? Plus the other elements. What HEM will ultimately allow, it's not there yet. This is very much a model being built out, but it would allow you to put wrappers, or say the actual external conditions and the actual internal conditions, and then do the calculation again and say, therefore, what's the energy use? So this is all about steps in a particular direction. The purpose of HEM, Jon mentioned it, the purpose of the HEM model is primarily to help people answer the HEM consultation questions, yeah? We can't help ourselves. I'm exactly the same, of saying, what does a house look like in it? How does a heat pump perform? What about wastewater heat recovery? That's actually isn't the point of a consultation model. They're trying to get this feedback, urge people to give that feedback. And if you think something's wrong with the model, there's something odd, then drop a line to BRE. You don't have to wait for the consultation response. There's a portal that you can jump on, yeah? Because this is about getting those responses in order for them to improve the model, yeah? It's kind of catch-22. They can't give a final model until they've gone through this process of asking people, what do you think about, yeah? So it's just keeping that in mind, whilst also recognizing people obviously will want to jump to what are the real answers. We're all the same, but that's kind of not the purpose.
And I would say on that, it's a bit of a shame that these consultations came out at the same time. It would have been better to have them running at separate times, because just the natural instinct is to combine the home energy model with ADL 2025. It would have been nice if one came after the other. But we are where we are.
We are, and it could be, John argued the other way too.
Yeah.
It's I guess, you know, we're on a bit of a pathway here. Just urge people to respond, and particularly think about the notional specifications that have been used. Yeah. Yes, it's a little bit nerdy, but for those that are in this space, there are questions there in the consultation asking for that feedback. Yeah. So do provide it. If house builders are concerned about the level of PV for option 1, that's question 7, I think. Question 8 gives you the opportunity to say what are your priorities, what are your concerns, and how to respond to that notional. So it is there, and it is important to respond.
That's great, thanks. And you mentioned the different weather areas that are used now within HEM, and I wanted to ask you, Paul. There's a question here about PV and the orientation. So rather than reducing the amount of PV in the notional, an easier change could be just to ensure the orientation matches the actual building, rather than always being set as south facing. What's the implication here? Is the notional is always south facing? How much difference is that going to make? Do you think?
Well, that's a really good point and a good question. And as I saw the comment in the question and answers. Yes, that's definitely something we should be pointing out to government in the consultation. And if you're using it would actually be a way of offsetting that by using the actual orientation as opposed to a notional one. Particularly bearing in mind, we think we spotted an error in the calculation where when it drops away from south, actually it drops rather more than it should do compared to MCS or SAP's calculations. So we've got a meeting tomorrow with Department of Energy Security Net Zero DESNZ to discuss that with them. But that certainly would make a difference. And I think that it needs to be practical, doesn't it? And you can't build a housing estate with all homes being south facing. It just isn't practical. So I think that's a good idea. And anything else along those lines, I think if anybody's got any further ideas around that, we should put those forward.
And I think, Adam, certainly Future Homes Hub have offered to DESNZ and Deluxe to get some people in the room to kind of chat through these things, because on the surface of it, that sounds a really good idea. But if the home faces east-west, then obviously you can put panels on both the east and the west. So what do you do in that circumstance? So all of these, it is quite interlinked. It's quite complex. And it strikes me as, needs a little bit more thought and nuance.
Yeah. And just to reinforce the point David made there, that the example Paul gave of looking at the numbers and saying this doesn't seem quite right, you don't have to wait till the consultation. Correct. Or put down a response. There's a direct route via the HEM kind of page on the BRE site where you can submit those concerns direct to BRE, and as we saw earlier in the presentation from John, things are changing even during this consultation period. So it may be that those could be a quick fix. And
it's worth saying they're really interested in areas that the building physics might be wrong. So something feels odd. Yeah. The heat pump change, though, was simply the heat pump that you could select was a very clunky heat pump that couldn't modulate down, which no one would actually ever install. I'm probably out on a limb here, but all air source heat pumps modulate down. So that one was just a wrong selection of product, which arguably at one level you could answer the consultation on HEM without having the right heat pump in there. But it set a lot of people running, because it's just deeply unhelpful. So seeing this improvement gets us into a better space.
Thank you. And just wanted to bring you in, Chris, on the ventilation side, because there's a question here about that. So option 2 doesn't require PVs, while option 1 does. although option 2 has worse off U values, is this due to the ventilation system? Maybe you could talk about the difference between the ventilation systems in the two options and what impact, how much difference do you think that's making in the scheme of things?
I'm not sure, to be honest with you. It might be one for John about how it affects the system. But I mean, the difference between the two systems, one is literally an intermittent system, comes on either automatically, manually, etc., which probably what most of you got at home. The other one is a continually run system that then boosts on a trigger eye light switch or moisture or whatever else it may or may not be. I'm not sure about how much of an impact that has within the energy model.
John, do you want to come in?
Yeah, well, from what I've seen, not a huge amount, particularly between intermittents and whole house, what used to be called system 3. They do seem to be on a par really in the home energy model. MVHR does perform better with a lower air test as you would expect to see, and as is the case in SAP. But yes, but between the whole house and intermittents, there's really not that much to split them.
Yeah, there's some interesting ones here just on battery storage, but we've got just 5 minutes left in the webinar, and I wanted to ask if anyone on the panel, if there are particular questions that have come in that you think are really important that you want to try and answer today. We won't be able to answer every question, but was there anything that anyone wanted to pick up in terms of questions in the Q&A?
So there were two questions around this 2-meter duct length and where it arrived from. There is no explanation that I've seen as to where it arrives from, but I think if we look at what we're doing at the moment, 99% of the problems we have are with installation, and if we drive people away from those types of systems to centralized systems, where probably there's more technical knowledge required to install them, then it will probably improve outcomes. That would be my assumption as to why it's been driven down that route.
Thank you. Any other questions that jumped out to people that they wanted to address?
I can pick up on the battery one if you like, because that sort of came up in 2 different questions. There's some suggestion that it should be included in option 1 and 2. I would suggest that certainly in option 1, it should be potentially given credit. So in other words, if people choose to install batteries, then that should be something that improves the situation, and it should be represented in the home energy model. With option 2, maybe slightly less so, because there's obviously no solar to store, although you can do arbitrage and things. But I think that's mandating that is difficult. I think in the sense that almost always it makes they're quite expensive. It makes the use case worse. But it should be there possibly as an option where people are able to use that to more easily and more readily to meet the standard, where maybe they're struggling in other areas.
And I think, Paul, this is where the metrics that have been chosen currently, and I kind of get why they might have done it. If there had been a metric for load shifting, then
yes.
You've got hot water load shifting, you've got fabric load shifting, and you've obviously got batteries to load shift. Yeah. So it will be interesting to see how much a battery has on the metrics that they've chosen, because the answer might be relatively little, but from a cost savings to the householder, that will be an output of this model. That doesn't mean you're not going to be given information to make that sales case. So we'll just have to see a little bit. The model itself is a good basis for understanding the benefits of those technologies, and gives. And there was a question there about getting other technologies within the HEM. I mean, part of the reason for the creation of HEM is because it will better represent more new innovative technologies, but clearly there is some work to get them in there. And we know that was been a problem with SAP, but it was always a workaround in SAP. I'm really hoping, and certainly from a Future Homes Hub perspective, we'll be pushing to try and make that pathway for innovative technologies smoother. And HEM should be a good basis for that.
Well, that's great. Thank you, David. And thank you to all the panel. I really appreciate the time in joining. We're going to wrap it up now with just a minute left. But I did want to remind people that this is one in a series of webinars that the Hub is running. We also have the innovation webinar series, which is running on a Friday lunchtime. The next one this Friday is on TM59, Dynamic Thermal Modelling in Practice. And the following week on the 30th of Feb, we've got the Heat Pumps, A Builder's Perspective. I know the Part O one was very popular. So hopefully these are informative. You know, we don't have all the answers. That's not why we're here. We're just helping to give you a window on some of the conversations that have been happening, and great to get your questions. So thank you everyone for joining.
Adam, one last one. Just a note to people, we will be posting the next few days a advice note on HEM and Future Home Standard, following some of the themes that have been cropped up. I'd have loved to have got it out before midday, but wasn't able to. But watch out for that, and perhaps we could email people to say that it's when it lands.
So that is exciting news, and thank you, David, for mentioning that. Once again, thanks to all the panel, much appreciated. Goodbye.
Thanks all.